I want to start today by totally transporting you to three completely different places on the map. First, just picture the Caroline Islands in the Pacific. Imagine this 12-year-old boy, a Pulawan sailor. He is miles from shore, just this tiny speck on the open ocean in a canoe.
Right, and with no GPS, no compass.
Nothing. No iPhone, no maps, just him, the water, and the sky. But he is totally at ease out there. He's navigating by the position of the stars, the specific feel of the waves hitting the hull, and this incredibly complex mental map of geography that he's been building up since he was a toddler. He knows exactly where he is.
Yeah, it's pure internalized knowledge. It's fascinating.
It really is. Okay, so scene two. Shift over to Iran. Picture a 15-year-old youth sitting in a quiet room. He has memorized the entire Quran. Every single verse, every inflection. He can recite it backwards and forwards.
Which, just physiologically, is a massive feat of linguistic memory.
Huge. And finally, let's go to a messy bedroom in Paris. There's a 14-year-old girl hunched over a computer. But she's not gaming. She's actually composing a symphony using a synthesizer. She's layering tracks, adjusting pitch, understanding these complex harmonies that most adults couldn't even hear, let alone create.
So we've got three kids, three completely different but undeniable kinds of mastery.
Exactly. But here's the problem. If we took those three kids, the sailor, the memorizer, and the composer, and we just sat them down in some beige classroom for a standard IQ test, what happens? You know the drill, defining vocabulary words, solving arithmetic problems for an hour?
They bomb it. Or, at the very least, the test completely misses what makes them special.
Right.
The sailor might struggle with the vocabulary section. The composer might totally bomb the logic puzzles, because that test is designed to predict one thing, and that's how well you will do in a traditional school in the year 1900.
Yeah, very specific setting.
Exactly. It tells us almost nothing about their actual potential for success in their own environments.
And that, right there, is the massive blind spot we are diving into today. We're unpacking the work of Howard Gardner and his absolute classic source material, Frames of Mind. This is the book that really introduced the world to the theory of multiple intelligences.
It's the book that totally smashed the idea that smart is just a single number you're born with. Gardner's mission in this book is huge. He basically wants to deconstruct the classical view of intelligence and replace it with something that's actually biologically accurate.
And he starts with this great analogy that I think sets the stage perfectly for you if you're listening. He borrows it from the poet Archilochus. It's this war between the hedgehog and the fox.
I love this comparison so much. So the hedgehog views the world through one single defining idea. In psychology, the hedgehog represents the traditional view of intelligence. We call it G, or the G factor.
That's a G for general intelligence, right?
Right. The idea is that intelligence is just this single power source in the brain. If you have a lot of G, you're good at everything. If you're smart at math, you're smart at history, you're smart at languages. It's all just one big muscle.
Which, honestly, is how most of us were raised to think.
Yeah.
You know, you're either the smart kid or you're the not smart kid.
That's the hedgehog view. But Gardner is firmly Team Fox. Because the fox knows many little things. The fox views the intellect as fragmented, split into several distinct components.
So it's not one big muscle.
No, Gardner argues that the human mind isn't a single general-purpose computer. It's a collection of distinct, highly specialized computers.
So the sailor has a navigation computer, and the composer has a music computer, and they might not even talk to each other.
In a way, yes. And he isn't just saying this because it sounds nice or makes people feel good. He's arguing that this is how our biology is actually wired.
Okay, but before we get to the biology, which is super fascinating, how did we get stuck with the hedgehog view for so long? I mean, why are we so obsessed with the single IQ score?
It's really a mix of history and convenience. But to truly understand it, we actually have to go back to the late 1700s and talk about phrenology.
Phrenology. That rings a bell. Was that the skull thing?
It was Franz Joseph Gall. He literally thought he could read your personality by feeling the bumps on your head.
Wow.
Yeah, he thought if you had a bump here, you were secretive, a bump there, you were hopeful. He had this whole list of 37 faculties, which Gardner points out was a real mixed bag of traits.
Okay, so clearly that is pseudoscience. Why does Gardner even care about a guy who is reading skull bones?
Because even though Gall's method was completely flawed, his core intuition was actually way ahead of its time. Gall was the very first person to really argue for localization.
Meaning what, exactly?
Meaning he believed that different parts of the brain mediated different functions. He didn't think the brain was just one big blob of jelly. He thought it had specific compartments.
Oh, I see. So he had the right map, just the wrong way of reading it.
Precisely. But then, as history does, the pendulum swung back the other way. In the early 20th century, you get Alfred Binet and the rise of the IQ test in France. This is where the hedgehogs really took over.
Because they needed a system.
Right, they needed a quick, practical way to rank students, basically to predict who was going to fail in a French classroom so they could give them extra help. The focus totally shifted to general intelligence measured by paper and pencil tests.
And a French classroom in 1900 valued very, very specific things.
Mathematical logic and linguistic ability. That's pretty much it. If you had those, you were intelligent. If you had spatial genius or musical genius, the test simply didn't care. It wasn't built for you.
Which brings us to a guy that Gardner seems to have a bit of a love-hate relationship with in the text, Jean Piaget. Now, Piaget is a total giant in developmental psychology,
Yes,
right?
massive giant. And Gardner deeply respects him. Piaget was the one who realized kids aren't just empty buckets waiting to be filled with facts. They're active builders of their own minds.
But he had a blind spot.
A huge blind spot. Piaget was obsessed with the idea of the young scientist. He mapped out human development as this inevitable march toward logical, mathematical thinking.
So he was basically studying how kids become good at science and math.
Exactly. And in doing so, he basically ignored the artist, the leader, the athlete. He assumed that if a child reached a certain stage of thinking, like abstract thought, they reached it everywhere across the board.
So if I can think abstractly in math,
Yeah.
Piaget assumed I should naturally be able to think abstractly in music or art.
That was the core assumption. But Gardner said, just look around. That's not how people work. You can have a child who is an absolute prodigy in music, but is totally average or even struggling in math. The mind doesn't grow in lockstep. Different faculties grow at totally different rates.
And this leads right into the origin story of Gardner's theory itself. Because he didn't just dream this up sitting in a library reading Piaget. He was living this sort of double life professionally, right?
Yeah. He was, and this detail is so crucial to his whole argument. In the mornings, Gardner worked as a neuropsychologist at a veterans hospital. So he was working hands-on with patients who had suffered severe brain damage, strokes, trauma, things like that.
And then the afternoon shift.
In the afternoons, he crossed town to work with normal and gifted children at Project Zero at Harvard. So he had this daily, split-screen view of human cognition.
That's a wild contrast.
It is! In the morning, he would see a patient who might have lost their entire ability to speak due to a stroke. They were totally aphasic, but they could still learn a new card game perfectly or appreciate complex music.
Wait, let's pause on that because that's huge. If intelligence was just one single general power, like the G factor, a stroke should just knock the power out for the whole building.
Exactly. If you unplug the main computer, the whole screen goes black. But that is simply not what happens in the human brain. You can lose one faculty like language and keep the others perfectly intact.
And that's what tipped him off.
Right. That suggested to Gardner that the mind has to be made of independent components, separate computers.
So he moves from just observing behavior to really looking at the hard wiring. He says biology is the court of last resort for this theory. And he gets pretty technical here, talking about two main forces, canalization and plasticity.
Yeah, these are essentially the two forces constantly fighting for control of your brain development.
Let's break them down for everyone. Canalization. It sounds like a root canal, which is terrifying.
It's actually more like a riverbed. Think about how rain wants to flow down a specific path because the ground is already shaped that way. Canalization is the idea that our nervous system is genetically programmed to follow specific developmental paths. We are prepared to learn certain things.
So language, for example, isn't just something we pick up casually. We're actually built for it.
We are channeled into it. Unless a child is completely isolated in a closet, they will learn to speak. Gravity does the work because the canal is already there.
Okay, so that's the rigid, pre-programmed part. What about plasticity?
Plasticity is the flexibility of the brain, especially early in life. If one part is injured, another part might physically take over that function. But this is where Gardner's biological argument gets a little intense. He cites these famous experiments by Hubel and Wiesel with kittens.
Oh man, I think I know this one. This is the visual cortex experiment, right?
It is. They showed that if you temporarily deprive a kitten's eye of light, basically sewing it shut just for a few days during a very specific critical period in the first few weeks of life, the neural connections for that eye literally atrophy. They die off.
Wait, even if you open the eye later, like after the critical period?
So even if you open it later, it matters less if it happens to an adult cat, but for a kitten, the brain just says, well, no signal is coming from here, so I guess we don't need these wires. and it repurposes that brain space for something else.
That is, I mean, it's terrifying, but it perfectly proves his point. It shows there are specific, hardwired timelines for specific skills.
Right. It proves critical periods exist for different faculties. The brain expects certain inputs at very specific times to build the vision computer or the language computer. It's not just a general learning machine.
He also mentions synaptic pruning, which sounds like gardening in your head.
It's exactly like gardening, but it's a brutal survival of the fittest inside the brain. We start out with a massive excess of neural connections. Development isn't just about growing new pathways, it's heavily about pruning, killing off the connections we don't actually use.
So if I don't use it, I literally lose it.
Literally. And the implication there is massive. It suggests that your education and your specific environment actually determine which of these potential intelligences physically survive in your brain.
That's wild. And he uses another biological example from the animal kingdom that totally blew my mind. Bird songs. I had no idea bird brains worked like this.
Oh, it's the ultimate proof of how specific learning is in nature. Take canaries, for instance. They learn new songs every year. And scientists found that when they learn a new song, specific nuclei, these little clusters of cells in their brains actually grow in size.
Now, their physical brain gets bigger when they learn the song.
Yes. And then when the mating season is over and they stop singing, those specific brain areas shrink back down. Seasonal brain changes.
That is crazy. It would be like if I studied for a calculus final, grew a new math lobe in my head, and then it just dissolved when summer break started.
That is exactly how specific the biology of learning is. And then he contrasts that with the chaffinch. Chaffinches are tuned to learn specific dialects. If they don't hear their own species song during a critical window, they never learn it. They can't just learn any song.
So they don't just have a general music ability.
Right. And humans are similar. We aren't just born with a bucket of general learning juice that we can pour on any problem. Biology supports the idea of specific isolated abilities.
Okay, so we've established the brain is modular. It has these separate components, these frames of mind. But here's the really tricky part. How does Gardner actually decide what counts as a bona fide intelligence? I mean, he can't just say, hey, I'm really good at knitting, so knitting is an intelligence.
Right. If he did that, the theory would be completely useless. He had to be incredibly rigorous. So he set up a very specific definition first. He says an intelligence is, and I'll quote here, the ability to solve problems or to create products that are valued within one or more cultural settings.
I really like that cultural setting part. It means intelligence doesn't just exist in a vacuum.
Exactly.
Yeah.
Like the sailor navigating by the stars, that is absolute genius in the Caroline Islands. But if you drop him in a windowless office in Manhattan, not so much. It has to matter to the people around you.
Right. But to avoid just picking random cultural skills, Gardner set up 8 specific criteria. He calls them the signs or the demons that must holler for something to be an intelligence.
And he didn't just guess. He used these criteria to filter everything.
He lists all 8, but I feel like they really fall into a few main buckets. Let's talk about the first bucket, which is isolation.
This is probably his strongest evidence. We already talked about brain damage, the negative proof. Can you lose this specific skill while keeping everything else intact? Think of Broca's area in language. If yes, it's distinct. But he also looks for positive proof, which is idiots, savants, and prodigies.
Sort of the Rain Man scenario.
Right. Or the musical prodigy who plays Mozart perfectly at age 4. Gardner calls this the fast-forward profile. It shows that this specific ability can exist at a genius level even if the person is low-functioning in every other way. If intelligence was all one general thing, you couldn't possibly have a 5-year-old musical genius who can't even tie their shoes.
That makes perfect sense.
Okay.
The second bucket of criteria, history.
This is looking at time in 2 ways. First, distinctive developmental history. Does the skill have a clear, observable trajectory? Does it go from babbling to speaking to writing poetry, from novice to expert?
And the second part of history is evolutionary history, right?
Yeah. Yes. Why do we have this test? Is it plausible that this trait evolved for survival? Spatial intelligence makes total sense for hunting and gathering. Bodily kinesthetic intelligence makes sense for tool use and escaping predators. If a skill doesn't have a plausible evolutionary root, Gardner is very skeptical.
Which brings us to a really interesting one, symbols.
He calls this susceptibility to encoding. Basically, can we create a symbol system for it? Humans are fundamentally symbol-using creatures. We have written language, we have math notations, we have maps for spatial intelligence, musical scores. If a capacity is distinct and important enough, humans will inevitably invent a system to record it.
And using all those criteria, he came up with the original 7 intelligences: linguistic, logical, mathematical, musical, spatial, bodily kinesthetic, interpersonal, and intrapersonal.
Yeah, that was the original list in 1983, and he was very clear about what didn't make the cut, which is just as important.
Yeah, I was actually thinking about this while reading. I'm pretty good at recognizing faces. I literally never forget a face. Why isn't face recognition an intelligence? Or smelling?
It's a really common question. And face recognition is biological, yes. It's localized in the brain. But does it pass the cultural product test? Do you create face products that are valued by society?
I mean, I guess not.
Uh-huh.
Unless I'm a portrait artist, but then that's spatial intelligence.
Exactly. Face recognition is a skill, a biological mechanism, but it isn't a full-blown intelligence in Gardner's framework because it doesn't have a symbolic system or a valued cultural product attached to it in itself.
That distinction really helps clarify things.
Hmm.
Now, whenever you have a theory this big, and this theory got huge in education, people are going to mess it up. And the biggest mix-up, the one that seems to drive Gardner the craziest, is confusing multiple intelligences with learning styles.
Oh, it absolutely drives him crazy. You hear it all the time in schools. A student says, "Oh, I'm a visual learner, so I can't read this textbook."
Right. Is that what Gardner is saying?
No,
Yeah.
absolutely not. He explicitly refutes this. Here's the core difference. An intelligence is a computing power. It's the actual hardware specs of your brain. A style is just how you approach a task. It's a preference.
Give me a concrete example of that.
Okay, take 2 different people. Person A has very high spatial intelligence. They can visualize complex machinery in their head, rotate 3D objects, the works. Person B has low spatial intelligence. Now, both of them might prefer to look at pictures rather than read text. That is a visual style.
But they're processing it differently.
Exactly. Person A is actually processing the complex spatial data effectively because they have the computing power. Person B just likes pictures. Having a style doesn't mean you actually have the intelligence for it.
So we really need to stop labeling kids as visual learners or auditory learners.
Sure. Right. Gardner argues we should look at their actual intelligences, their proven capacities, not just their superficial preferences.
Another really interesting nuance he brings up is how these intelligences aren't just totally walled off from each other in the real world. They interact. He uses this great metaphor of the laser versus the searchlight.
It's a brilliant distinction. So the laser intelligence refers to the specialists. Think of the concert violinist who lives and breathes music. Their intellectual profile is a massive spike. Huge musical intelligence, but maybe average or even low in everything else.
They're laser focused on one domain. And the searchlight.
The searchlight is the generalist, the politician, the business manager, the lawyer. They might not be a prodigy or have the absolute highest score in any single domain, but they keep a flat, broad profile across many intelligences. They use a combination of interpersonal, linguistic, and logical skills to monitor everything around them.
They're the ones constantly scanning the horizon.
Exactly. And Gardner suggests that while we definitely need lasers to push specific fields forward to write the symphonies and invent the tech, we desperately need searchlights to actually run society.
Before we get to the big takeaway, we should probably mention the list of intelligences itself. It wasn't permanently fixed at 7, right?
No, Gardner is very intellectually honest about this. He later added the naturalist intelligence, the ability to distinguish among nature's plants and animals, which clearly has evolutionary roots. And he heavily considered existential intelligence, the capacity to tackle deep questions about human existence. Though he hesitated to fully lock that one in, he admits the list is never truly final.
Which brings us to the big so what. We've talked about reading bumps on skulls, kittens with sewn-up eyes, and Puluwat sailors navigating the Pacific. But for you, the person listening to this right now, why does this theory actually matter?
It matters because, unfortunately, our world is still largely built for hedgehogs. Our schools, our standardized tests, and our corporate hiring processes still heavily prioritize linguistic and logical skills above almost everything else. If you don't fit that profile, you're often left behind.
So what's Gardner's solution? He has this sort of elevator pitch for educators and leaders, doesn't he?
He does. It boils down to 2 words: individualize and pluralize.
Let's unpack those.
Yeah.
Individualize.
Individualize means acknowledging that we simply don't all have the same mind. We don't have the same one intelligence. We have unique, jagged profiles. Whether you're a teacher, a manager, or just looking at your own life, you need to know the specific intellectual profile of the person you're dealing with.
You have to know what computers they're working with. And pluralize.
Pluralize means teaching important topics in multiple ways. If you're trying to explain a complex concept at work or in a classroom, don't just write a dry memo. Tell a story for the linguistic mind. Draw a diagram for the spatial mind. Create a role play for the interpersonal mind. By providing these different entry points, you naturally reach more people.
There is a bit of a warning here in the text, though. Gardner really didn't want this theory to just become a new way to pigeonhole people.
Right. You don't want a teacher saying, oh, Johnny is a bodily kinesthetic kid, so just let him run laps and don't even bother teaching him algebra.
Or someone saying about themselves, well, I'm not math smart, so why even try?
Exactly. That is incredibly dangerous. Intelligence is a potential. Yes, it's a biological propensity, but it deeply interacts with culture and effort. You can and absolutely should develop your weaker intelligences. The theory is meant to open doors for people, not close them into new little boxes.
Gardner ends on a thought about leadership that I found really provocative, especially today. Goes back to that laser versus searchlight idea we were talking about.
It's a really profound point to leave on. He suggests that in our modern world, we actually have plenty of experts. We have leaders within very specific domains, great scientists, amazing coders, brilliant musicians.
But we lack leadership for the wider society.
Right. Because everyone is so hyper-specialized, we lack those searchlight figures. We lack leaders who can weave a narrative that actually connects all these different intelligences together. He essentially asks, in an age of extreme specialization, which intelligence is most critical for connecting us all?
Let me guess. It's not the one that scores highest on a traditional math test.
Probably not. It's much more likely the ability to tell a unifying story, to construct a narrative that genuinely resonates across all those different frames of mind. The ability to speak to the sailor, the memorizer, and the composer, all at the exact same time.
Man, that is a lot to chew on. It really makes you look at your own brain and the brains of everyone around you a little differently.
It certainly does. It's a deeply liberating theory. It basically gives us scientific permission to value the full, massive spectrum of human potential.
Which is exactly why we wanted to do this deep dive today. Thanks for exploring this with us.
Anytime, it was a great conversation.